Hi, welcome to the topology optimization session. We are good to continue to the next step, which is defining objectives. Again, we will start with the upper stream, which is the dimensioning topo, or the first stream. And I think I mentioned before, we want to minimize the mass for this design, which is why we'll use the mass response component. It only needs a name, or it doesn't even need a name. There's a default value in here. I won't plug in a name. I'm happy with the default value. Mass response sounds good. And then I will use the FEM objective component, plug in this name and this response. And now I can set a goal. So I want to minimize the mass. I could also choose to maximize it. And I can plug it into the output. So yeah, the optimization will try to find a design with the smallest possible mass while not exceeding the values that we set here in the constraint. So this maximum stress and the maximum displacement value. All right. So now that we have defined this objective for the dimensioning topo, let's go down to the second stream, the non-dimensioning topo. For this stream, our objective or our goal for the optimization is to find the stiffest possible design, and we want therefore find the design that has the smallest response to the load step. And we will use the weighted compliance response component, use that name and enter the load step. And here you would have the possibility to enter different load steps and weigh them differently. However, we only have one here. It's a simple example. That's definitely enough to get into the whole topic. Okay, and now we also need the FEM objective. We will plug in that response. So we want to minimize the response of the design to the load step, therefore get the stiffest possible result. You could also set it to maximize, and now we would be looking for the most flexible result, the result that has the greatest possible response to the load step. As we're looking for the stiffest result, we will set it to minimize and can plug it into our objective output. Okay, so now in the fourth step, those different streams for the dimensioning and non-dimensioning topo meet again. So no matter which of those optimization you want to run, now it's the same process again. So now to actually run the optimization, you need the OptiStruct optimizer, plug in the name, the FEM model that we got all the way from here, from the input. We haven't touched it since. Here we are. And then the constraints and objective. So I've prepared here the constraint and objective for the dimensioning topo, and here for the non-dimensioning. You can choose which one you would like to run. I will go with the non-dimensioning one and connect them to here. Now we also need the topology variable, which is all the way here. Just use that wire and drag it all the way here. And now our OptiStruct optimizer starts running. So what the optimizer does is calculate a density distribution for all elements in the model, assigning them a density between 0 and 1. That value is called the ISO value. And it gives information about how much this individual element contributes to the stiffness of the model. So 0 means it doesn't contribute at all. 1 means it highly contributes. You can also use this drop down and set maximum iterations here. If you don't want to wait as long, you can decrease them. You can also set to different number of processors if you don't want to use all processors of your computer. Enter a different solver path if, this might be interesting if you can't find your solver directly. And also enter arguments to further individualize your optimization. Alright, so the component has run through and we get our result, which is the result of the last optimization iteration. And then also, if you plug in a panel into the info output, you can read that the operation is completed. And if you connect it to the successful output, you will read true if there has been any issue. If the optimization didn't work or you didn't get a license, you will read false here. So this is always good to check. In case you don't have an Altair license and you couldn't run the optimizer, here you get both of the models prepared. And now we can actually continue to display our result. Before we do that, I will select everything and hide it so that we only see our result. I will use the result isomesh component right here and then use the ISO value slider, which filters the elements. So right now it's set to 0.8 and it doesn't look good, the result. And what it means is that every element that has an ISO value below 0.8 is not contributing to the model right now, or to the isomesh. It's not included. So let's go down a little bit, maybe to here, or even further until you're happy with the result. Feel free to use the slider and adjust your result. As I mentioned before, so this is the non-dimensioning topology optimization that I just ran. So we get a rod-shaped result, which is very discrete. All right, and the mesh doesn't look super nice, so I will just quickly smooth it to get a better looking mesh. Enter smoothing strength. And now we have something that looks a bit nicer. All right, I'm happy with that result. And this is our output. We reached the end of this workflow. Maybe we can just check out what the other stream looks like. Have a check. So this was the dimensioning topo, which is more of a volume body, and maybe the ISO value can be a bit higher in this case. In this session, you got an insight into what steps are needed to set up a topology optimization workflow in our software. You are now able to transfer this knowledge to your own product development processes.